Hello and welcome to an introduction to trigonometry. In this video you won't need any prerequisites or anything. I'm starting from trigonometry from the ground up. So if you've never done trigonometry before, I think this would be a okay video to watch. Obviously there's probably other better videos, but I'm going to give you a basic introduction into trigonometry. So the study of trigonometry explores relationships between angles and side lengths of triangles. So in this video, to start off, we're just going to look at a basic right angle triangle. And we're going to be looking at SOHCAHTOA and sine, cosine, and tan. So let's just consider a right angle triangle. Okay? And you have an angle here. It was discovered there was there's basically three relationships you can have this triangle. So we have this thing, so opposite of our angle is of course opposite. And we have this thing, and we just call it opposite, denote it with O. And then next to our angle, which is just here, we have this thing called the adjacent side. So this is the adjacent, let me see if I can spell adjacent right. A-D-J-A-C-E-T, adjacent side, I think that's how you spell it, and we denote with an A. And we have this thing called the hypotenuse. Let's see if I can spell that. Hypotenuse, and we denote with H. I don't know if that's how you spell it, but we just denote with H. And basically, it was discovered these three, you can have them in ratios. If you have, we've got these things called, these are like new operations. These are called sine, cos, and tan. And basically, they're compositions of the ratios of these sides. So sine theta is equal to the, oh whoops, I forgot the theta. You need to have an angle there. So sine theta is equal to opposite over hypotenuse. So sine of whatever angle is in here is equal to the opposite side divided by the hypotenuse. This is for right angle triangles. Cos theta is equal to the adjacent side divided by the hypotenuse. And tan theta is equal to the opposite side divided by the adjacent side. So if you want to copy these down, I would copy these down because these are extremely important. So basically you kind of have to remember these, and the best way to remember them is using a thing called SOHCAHTOA. So just remember this acronym, SOHCAHTOA. Right? If you remember this acronym basically, it corresponds to each of the corresponding trigonometric ideas. So SOHCAH, the S means the sine, the O means the opposite. Oh, whoops, opposite. And the H means the hypotenuse. Okay? Same with the this part here. CAH, that corresponds to cos, that corresponds to adjacent, and that corresponds to hypotenuse. Okay? And TOA means tan, opposite, adjacent. So if you want to remember these trigonometric ideas here, all you gotta do is remember SOHCAHTOA and you can pretty much spit them out, pretty much. Alright, so if you want to copy that down, those are some really important ideas, everything on this Word doc at the moment. So feel free to pause the video and copy this down if you want to. Alright, so why do we need these new ideas of like composing the side lengths of triangles? Well, we have we basically, if we got given an angle of a side here, the angle here, and we had a side length like h here, using trigonometry, we could work out this and that if it was a right angle. This is only if it was a right angle. There are other ways you can find the other side lengths if it wasn't a right angle triangle, but you don't need to know that just yet. So I'm just going to move all this into the corner. Make it very small so you can still see it, but it's not directly in our way. Alright, and that's going to be our table of notes, pretty much. Alright, so I think the best way to see this is if we put it in action. So of course, for trigonometry, you need a I'm not even going to bother. I don't want to misspell calculator in a math video. You need a calculator. So there'll be a button. It will be a sine, a cos, and a tan button on your calculator. Best way to think of these things is operations. Okay, and secondly, you might also have a sine inverse button, a cos inverse button, and a tan inverse button. Or you might need to do second function to get those. So why do we need sine and tan inverse? So let's say we had sine theta equals let's say 3 over 5, and we wanted to find what theta was. Okay, we'd have to sine inverse it. So you'd leave theta on this side and you would do sine inverse of this ratio here to work out the angle. Okay, so plugging that into our calculator, 3 over 5, sine inverse 3 over 5 is equal to 36.86 degrees. And you can check if this works properly. So if you went sine of 36.86 degrees, of course there's other decimals there, but if you did that, you'll approximately get 3 over 5. Okay? So knowing that, we'll just rub that out now, and let's have a go at a basic problem. Well, let's put ideas into action pretty much. So let's say you were given a right angle triangle here, and you were given an angle of 29 degrees, and you had a length of 7 up here, and you wanted to find the height of this triangle. I want you to tell me which of these we're going to use in this problem, and B, I want you to try and find the height if you can. Alright, feel free to pause the video and have a go at this. Okay, so just starting off with our angle, we'll go our angle here. We have opposite, adjacent, hypotenuse. So we have so, ka, to, a. Okay? We don't have any information about the adjacent, so we're not going to use cos or tan because we don't need to find it. We want to find the opposite, and we've got the hypotenuse and we've got an angle, so we're going to use sine. So sine theta equals opposite over hypotenuse. Alright? So now we've got that. We don't really need to know about our adjacent now. So filling this out, our angle is 29 degrees, so sine of 29 degrees is equal to, our opposite is x, divided by our hypotenuse is 7. Okay? So to get x by itself, we just need to multiply both sides by 7. So therefore, 7 sine of 29 degrees is approximately, is equal to x. Oops. And using our calculator, 7 sine of 29 is approximately, you'll have to use your calculator, you wouldn't be able to do it otherwise, is approximately 3.39, yeah. If there was units, I would put your units here, but there isn't in this question, so you don't need to. Alright, so that's the answer. That is the height of our triangle. Alright, rubbing that out, let's have a go at another one. Alright, let's say we had another right angle triangle. I'm just going to draw this, yeah, I'm just going to draw this one a bit differently. I'll draw it like this. So it's a right angle triangle. Our angle is 53 degrees. We have a length, we have 2 here, and we want to find x here. So feel free to pause the video and have a go at this. Alright, straight off the back, mark our angle here. Opposite, adjacent, hypotenuse. So, ka, to, okay? Alright. So we want to find our hypotenuse, so we have to use sine or cos. We don't need tan. Tan won't help us. We've given the adjacent. The adjacent isn't in sine, so we have to use cos. So cos theta equals adjacent over hypotenuse. Right? So therefore our angle is 53, so cos of 53 degrees is equal to adjacent, which is 2, divided by our hypotenuse, which is x. Alright, so we need to move the x up there, so we're going to multiply both sides by x. X cos 53 degrees equals 2. Now we're going to divide by cos of 53 degrees on both sides. Cos of 53 degrees. So x is equal to 2 cos of 53 degrees. Have that in your calculator. Using a calculator, x is approximately 3.32. Okay? Alright. Rub this out and we'll have another go at one more example. So consider this right angle triangle. We had a side length of 10.3. We have an angle of 75 degrees and our x is here. Alright, so feel free to have a go at this problem. Pause the video. Alright, first thing we're going to do is label our angle. So go opposite, adjacent, hypotenuse. And we know so, ka, toa. We have an adjacent. We want to find an adjacent, so we're not using sine, so we have to use cos or tan. We don't have a hypotenuse, so we can't use cos, therefore we must use tan because we want to find the opposite. So tan theta equals opposite over adjacent. We have our angle is 75 degrees, so tan of 75 degrees is equal to 10.3 over x. And we're going to do the same thing like we did in that other problem. Move the x up there and move the tan 75 down there. So x is 10.3 over tan over 75 degrees. If you're wondering how I did that, it was pretty similar to the last problem. I multiplied this side by x, cancelled that, and then I divided by tan of 75 degrees on both sides. Okay? So that's how I moved from this to that, pretty much. And using our calculator, x is approximately, we just got to use a calculator, 10.3 divided by tan of 75 degrees is approximately 2.759. Alright, this was a basic introduction to trigonometry. I'll be making a part 2 to this probably. If you enjoyed the video or you learned something new about it, give it a thumbs up and share it with someone if they're learning basic trigonometry. Thank you for watching.